Today's lesson is your review for your Unit 1 test. One of the first couple of questions that you're going to see on your test is going to ask you to graph a given function, give me its parent function, and tell me about the transformation. When you go to graph it, please make sure that you graph the parent function. Since this one has a square right here, this one is the quadratic. Remember, you can write it or you can go ahead and tell me the parent function's equation. Don't forget to graph the parent function. Going into the table in the calculator, you can find your set of ordered pairs and you can plot what you can. I could even go to 3 and 9 and negative 3 and 9. Guess I could go ahead and plot those as well. Plot what you can on the graph. So there's the parent. There's no need to label it. I know which one is which just by the way that they have been graphed. And then please make sure that you graph this one as well. I've gone ahead and done a table. And let me go ahead and plot those points for you. 4, -4, -3, -5. There we go, something like this. There we go. All right, now per my transformation, I can use this f of x down at the bottom. Remember that when there is a negative after the equal sign, you want to use the words flip or flipping or flipped, or the word reflect or reflected or reflecting. This should say over the x-axis as well. Don't forget that it is the x-axis. But you're only going to use this if the negative comes right after the equal sign. Take a look at ours. Here's our equal sign. Right here is where that negative should be, and there's nothing there. If there is a number after, oops, there we go. If there is a number right here after the minus sign or after the negative sign or after the equal sign, then you should see words like stretched or stretching or stretched by or compressed. And it just compressed or compressing. It just depends on what type of number it is. Remember, a stretch would be by a factor of a whole number, 2, 3, 4, 5, 6. A compress or a compression would be by a factor of a fraction, 1/2, 1/3, 1/4, 1/5, 2/3, 2/5, something like that. All right, this guy right here is my parent. This guy right here is my parent. As it is written right now, it is the linear parent. If I want to make it the quadratic parent like up above, then I need to have a square right here. That's how I knew this one was the quadratic. Notice as well, where A is, there is nothing here after our equal sign. A should always be the number in front of the parent. There's nothing there. So there's no stretch, there's no compression to this graph. All right, my parent, remember to be a quadratic, it needs a square here. To be a cubic, it needs a cube here. To be a root, there's the square root, there's the cube root, and there's the absolute value. Those are the ones that you're going to see. Make sure you have the symbols that the parent needs. This is the linear parent as it is written. All right here, this guy inside, remember, is our tricky faker. This one is our tricky faker. It's totally faking you out. It's moving you right or left. Okay, remember it's trying to trick you out. So I would think that to the right should be positive, but it's really going to look negative inside. So when it's minus, it's really to the right, and when it's plus, it's really to the left. This is because this is your horizontal motion, and if you look here to the right are my positives, and here to the left are my negative numbers, right here on my number line, starting here from 0. Um, but if I want to move the graph to the right, I actually need to put a negative into the symbol. So it's making me it's trying to make me think it's moving to the left when it's negative, when it's really moving to the right, and vice versa. All right, so let's take a look right here. This guy right here is my tricky H value. I want to say to the right because it's positive, but I'm going to actually say moves 3 units left. I just need to see that it's 3 units left. And then the last part, this guy right here, K, he is the real deal. He's the one, or she's the one that shows up when they say they're going to show up, that does what they're going to say they're going to do. Up or down. Up is positive, down is negative. And it looks that way because it is the real deal. So when I see plus K, it's up. When I see minus K, it's down. Here is my K value right here. And I'm going to say, and down 5. I could put units. Perfect. It doesn't have to be a complete sentence. I need to see 3 left, 5 down. There's no flip, there's no stretch, there's no reflection. All right, so that's the first couple. Please do not forget that you do need to graph both the parent and the transformation. You need to graph both of these. All right. The next couple of questions are going to ask you to write the equation for each of the following. So it's going to give you a start to your f of x, and then it's going to give you some parts of this guy right up here. Just remember that you're going to go ahead and you're going to follow along. So compress by a factor of 3/4, shift right 5, and up 4. Okay, so compressed by a factor of 3/4. This 3/4 is what's going to become my A value. And since there are no words for your flip or reflect, we're going to just ignore it. Since these words were not here, this symbol does not exist, and we're going to start right here with the compress by a factor of. That A value becomes this number. This A value becomes this number. I'm next going to start with my parentheses, the x. I'm going to leave it a minus for right now, and then I'm going to decide if I should come back and make that a plus. Okay, I'm looking for the words right or left, and I see right here, right 5. Right 5. Okay, I need to decide. Now, right to me would be positive, so it's really going to stay minus, and the h is going to become 5. This is a linear function, so there's nothing that needs to be added to my parent. My parent is just x. My parent is just x. So remember, as it is written, this is the linear parent. As it is written, this guy right here is the linear. So the last thing I'm looking for right here is my real deal, up or down. Let's see what it says. And up 4. It's the real deal. I think up is plus 4, so I'm going to go ahead and put plus 4. That's it. I'm done. Okay, remember there's nothing to add to that linear function, but if I had a quadratic, which hint, hint, you could have on the quiz, on the test. You could go ahead, you would go ahead, not could, you would go ahead and add the square right here to the parent. All right, moving on. The next couple of questions, there's going to be two of them that are going to ask you to use interval notation to describe the domain and range of the given graph. We are also going to ask you to evaluate the graph. Oops, I thought I had my laser. We're also going to ask you to evaluate the graph. Let's go ahead and go over domain and range. Remember that the domain are your x values. These are your x values. So you want to look at your x-axis. Let me grab my blue highlighter and let's highlight that blue axis, that x-axis. All right, what you need to do is you need to read this graph starting over here at the left side, and you're going to read it in the direction to the right side. Remember, over here on the left side, you have negative infinity. And over here on the right side, you would end with positive infinity. Now, that is only true if your graph does not contain, if your graph contains arrows. If your graph does not contain arrows on the ends, then it's not continuing forever, and you just need to read it from point to point. Okay, I'm just reminding myself that negative infinities on the left side and positive infinities on the right. For a graph like this, which happens to be an absolute value graph, I'm going to grab this vertex and I'm going to pull it down to the x-axis. Now I'm going to think about this side of my graph and I'm going to ask myself, does it ever stop? Well, no, it does not. So my graph is going to do this from the vertex on the right side. All those points that are slanted are going to come up or down and just fall in on their x values to the x-axis till positive infinity. Likewise, let's pull that vertex down. The left side of my graph, is it ever going to end? No, it is not. So it would just fall into line right here. If I go ahead and look at it, yes, my vertex is right here, but it's going to positive infinity and to negative infinity. So it's just simply filling in everything. Interval notation, remember, is using my symbols with my parentheses and my brackets. And I'm doing it from left to right. So I could even come in here and say it's doing this, right? Let me see. Let me make that a little bit thicker. There we go. There is my graph. So I would say negative infinity, comma, positive infinity. And then I have to go back to lesson 1.1. Infinity is always considered open because we never know where it truly ends. And so we want to use the parentheses. All right, my range, let me change my color really quick. My range are my y values. And so I need to go ahead and I need to follow my y-axis. Let me change this quick. There we go. There's my y-axis. So I need to see this graph on the y-axis. One of the first points that I should gravitate to specifically on a absolute value graph is the vertex. I'm going to pull that vertex over. It is closed because remember, if I want the point to be open, I have to obviously make it look open to you. It looks like it's right there at 2. That looks like it's at 2. And if I look at my graph, both the left side and the right side are heading down. And so they would do something like this. Okay, so this is what my graph appears to look like. I just have to remember how I read this graph. Now remember, when we read the y-axis, we read it from the bottom, which happens to be where our negative infinity is, up to the top, which happens to be where our positive infinity is at. So if I start reading this graph from the bottom, I would start at negative infinity, comma, and then it would end right here at the vertex of 2. So I'm going to stop it right here at 2. There's no graph up here above 2 on the y-axis. Infinity always gets the parentheses, and the 2, since it is closed, it was a closed point on my graph, I'm going to give it the bracket. There we go. Now remember, when doing this last part of this problem, we are just simply reading our graph. Now remember that this part is x equals, and this part is y equals. So what this problem is telling you is saying, well, y is equal to 8, what's x? All you have to do is go to the y value of 8. It should be this one right here. Here's 8. And then you have to find the graph. The graph should be to the right or to the left, not up or down. The graph should be to the right or to the left. There's no graph. So we're going to say none. There's nothing there. There's nothing there. NA doesn't exist. Okay? Doesn't exist. There's no graph there. Okay? Because this was my y value and not my x value. If this had been switched, if the 8 was here and the blank was there, then x is 8 and I need to find out y. I would go to 8, 1, 2, 3, 4, 5, 6, 7, 8. Here it is. And I would come down. Here's my graph. I'd read it over and it would be negative, what, 1, 2, 3, 4, 5, 6 maybe? Okay, but they were switched. There's no graph. If it's y, I have to read to the left or the right to find my graph, and it's just not there. All right, let's take a look at another one. There's one question on today's test that's going to ask you to use set builder notation to describe the domain and the range. So once again, remember that your domain are your x values. When you read, let me go ahead and change this. There we go. These are your x values, just really quickly, one more time. We're reading from the left, which is where negative infinity lies, over towards the right, which is where positive infinity lies. All right, I need to grab this point. I need to grab this point right here, and I need to pull it down to the axis. This is considered a closed point. Remember, if I wanted it to be open, you would see it as open as such. So this is a closed point. I'm going to pull it down. There it is. -1, -2, -3, -4, -5. So I'm going to pull that point right there down to -5. I can see that the graph is heading in this direction. So from that point, it would go just like this. It's never stopping. The graph is never stopping. So my graph would simply do this along the x-axis. To write that in set builder notation, I need to start with the squiggles, use the letter X and the vertical line for all the values of X such that, and now I need to write an inequality. Since there's only one number on my line, -5, this is simply x is greater than or x is less than -5. That's all I have to decide. Are the numbers on that blue line bigger than -5 or smaller than -5? Well, the infinity that you see is going to dictate that. It's going to decide that for you. Since we are heading towards positive infinity, they are bigger than -5. If we were heading towards negative infinity, we were shading this way, then we would say less than. And of course, if we were doing less than, then the graph would have to look like this. Just a heads up. All right, the point at -5 is closed, so I need to make sure that I put the bar underneath. Then that's it. Let's practice one more time with our range, which are our y values. Remember that we read our y-axis from the bottom, which is where negative infinity is, up to the top, which is where positive infinity lies. And I'm reading along this axis. I need to pull in those points. The first point I want to pull in is that starting point, which had an x value of -5. I'm going to pull it in right over here, and it has a y value, it looks like a +3. Now I need to ask myself, where are these points going to go? Well, as I pull them over, they're all going to end up pointing down in this direction. They are not going to be up above. I can see that above there is nothing. There's no graph, none at all. But below there is a graph. So the graph will look like this. There we go. And we're ready to go ahead and do our set builder notation. Start with the squiggle, use the variable y because that is for range, and then draw your line such that. Don't forget to use the letter y once again, and you're going to use 3. Because you only have one number and an infinity, this is a less than greater than situation, and all you need is y and the number. You need to put y first and then the number. Leave space to decide, is it less than or greater than? Remember, the infinity is going to tell you negative infinity is always less than, positive infinity is always greater than. So since I see it going towards negative infinity, I'm going to use less than. Since the 3 is closed, I'm going to put my bar underneath, and I'm going to finish with my squiggle. The last question right here is going to ask you to do some evaluation of the graph. Remember, once again, this number, when it is inside, this is your x value. So x is equal to 6, and we want to know what y is equal to. The graph is going to tell us. Go to where x is 6, 1, 2, 3, 4, 5, 6, and go to the graph. My graph is above. Here is my graph. I only had to go up 1. My answer right here is 1. It's just that easy, okay? All right, the last few questions on your test are going to ask about the inverse. First, we're going to determine if each pair of functions are inverses of each other. You must show the substitution and simplify completely so that you can get full credit. Now remember, we are doing substitution, so it's completely up to you how you would like to substitute. I think for this one, I'm probably going to do g of f of x, which means I am going to take my f of x right here and plug it into the x in my g of x problem. So I'm going to make those into parentheses, and this guy is going to be replacing the x over there. I'm going to keep my my fraction, just like so, but instead of putting x, I'm going to place in here 8x minus 7. Now, the parentheses are not for distributing. This is not distributable because it has a plus 7. So I cannot actually distribute that. If I were to distribute, there would have to be a number right here, like 2, or there would have to be a number right after here, like 3. There's neither, so I can go ahead and simply think of this as 8x minus 7 plus 7 divided by 8. All right, I'm going to go ahead and look at the top, and I'm going to say there are 1, 2, 3 terms. 2 of them are like terms, and I'm going to put them in the calculator and combine them. That would be the -7 plus the +7. -7 plus +7 is 0, and they disappear, leaving me with 8x divided by 8. Whenever you get to this stage and you need to divide, remember you are dividing 8 by 8, which does cancel to give you 1, which leaves us simply with x. This is what I get when I'm done simplifying. Per our notes in 1.6, if we get x when we simplify, they are inverses. So are they inverse? I could say yes, inverses. Let's take a look at this one more time. I'm going to go ahead this time and substitute, trying to think. I think it would be better. Ooh, I don't know. It might not be better either way. Let me see. Let's do this one in right here. So let's substitute this in for x. Remember, we're putting parentheses around that x. So I'm doing, once again, g of f of x, because I'm going to be plugging f of x into g of x. It's not so much important that you get this symbol correct. It's just that you get your substitution correct. So I'm going to start with the 3, and then I'm going to go ahead and I'm going to substitute in the f of x function. So there it is. And I'm going to add that plus 7 because that was from g of x. Now for this one, I do have to substitute, or I do have to distribute. Notice there is this number here in front of my parentheses. I must distribute. So 3 times 1/3, remember the fractions are going to cancel each other out, leaving me with x. That's good. And 3 times 7. Okay, this is what I have. I've distributed, and then I have my plus 7, which is from this guy right here. All right, I'm going to go ahead and combine my like terms. That would be my positive 21 and my 7, which gives me x plus 28. There's nothing more I can do to simplify. I have nothing over here. There's nothing here. So I can't solve, right? I'm not solving, I'm just simplifying. There's nothing more I can do. This is what I got. This is what I got when I simplified. So my would be no, they are not inverses. They are not inverses. All right, I think I have one last question for you. Yes, I do. This is the last question on the test, and it's going to ask you to find the inverse function for the following. You do need to make sure that you show all your steps and simplify completely. This is the one where we have to change g of x to y, and then we're going to go ahead and switch our x and our y. So we're going to go ahead and we're going to change this to y, and we're going to change this to x. Once I have completed this step, I'm going to go ahead and want to solve for the variable y. I want to get the y alone. There we go. All right. Now, for a fraction like this, which you are going to have on your test, the first thing you want to get rid of is the denominator. You want to get rid of that 3. You need to think of the fraction as being division. So this fraction bar right here is really the division symbol. To get rid of it, you're going to multiply by whatever's in the denominator. What you do to one side, make sure you do to the other. 3 times x is simply 3x, and then you simply have your numerator, or the y plus 9, left. All we've got to do now is get that variable y by itself. I'm going to focus on getting rid of this addition, because you should be getting rid of the addition or subtraction next, by doing its opposite, which is subtracting 9. I cannot actually subtract 3x minus 9 because they are not like terms. The x says no, you cannot subtract. So all I'm going to do is take their format, which is vertical, one on top of each other, and I'm going to write it horizontally. That's all I can do. I have completed, and this is my answer. I just need to make sure that I write it in the proper inverse function notation. So I start as g of -1 of x, and then I put the 3x minus 9. Good luck on your quiz or on your test.